In early December, scientists witnessed a cosmic event that shook the world of astronomy. An object entered our solar system that wasn't born here. It wasn't a fragment of a planet, nor was it an ordinary comet. It was an interstellar visitor, 3I/ATLAS. That is, a comet that formed around another star and traveled billions of kilometers to pass through our solar system. But the real surprise came when scientists observed that this comet was emitting X-rays. Yes, the same X-rays that we commonly use in hospitals to see inside the human body. Now imagine, why and how could a comet in the middle of space emit X-rays? The European Space Agency's, ESA, powerful XMM-Newton space telescope recorded this mysterious phenomenon. This is no ordinary occurrence, as X-rays are usually observed only in very energetic and specific circumstances. When an interstellar object enters our solar system and begins emitting X-rays, it means that its internal structure, its gases, and its behavior are telling a completely different story. For scientists, this is not just a discovery, but a new door to understanding the materials formed around other stars. But the question is, what did 3I/ATLAS do to cause the emission of X-rays? Is it the effect of colliding with the solar wind, or does it contain an element that is not found in ordinary comets? And the biggest question, will this discovery help us identify more such interstellar visitors in the future? The answers to all these questions will gradually unfold in this video, so stay tuned until the end, because the final information might surprise you the most. Subscribe to the channel so you can be among the first to see such videos. Before understanding what scientists have observed regarding 3I/ATLAS, it's important to understand what an interstellar object is and why 3I/ATLAS is considered so special. In simple terms, interstellar objects are celestial bodies that did not originate in our solar system. They formed around another star, and then, for some reason, left their home system, wandering through space before entering our solar system. Our planets, comets, and asteroids all formed around the Sun and orbit within its gravitational influence, but interstellar objects break this rule. They come from outside, pass through quickly, and then return to interstellar space. So far, humanity has observed very few such objects. In 2017, scientists first observed 1I/Oumuamua, which surprised everyone because its speed and direction clearly indicated that it did not originate in our solar system. Then, in 2019, an interstellar comet named 2I/Borisov was discovered, which behaved like a typical comet, releasing gas and dust. Now, 3I/Atlas is the next in this series. Every new interstellar object is incredibly valuable to scientists because it provides a direct sample of material formed around another star. Without actually traveling there, we get a glimpse into another star system. Now the question is how 3I/ATLAS was discovered. It was identified by ATLAS, the Asteroid Terrestrial Impact Last Alert System. This is a special survey system where ground-based telescopes continuously scan the sky. Their purpose is not only to find asteroids that pose a threat to Earth, but also to detect any object moving unusually fast or following an unusual trajectory. When 3I/ATLAS was observed, its speed immediately caught the attention of scientists. Ordinary comets and asteroids are bound by the Sun's gravity, so their orbits remain within a defined range. But 3I/ATLAS's speed was so high that it became clear the Sun couldn't hold on to it. Scientists calculated its orbit and found that it was traveling in an open, hyperbolic trajectory. This meant one thing. It had arrived, it would pass by, and it would never return. This is what sets it apart from typical comets. Furthermore, its direction is also significant. Its path is not like that of objects usually found in the solar system. It came from a different direction, indicating that it originated from a distant star system. This is what makes it so exciting for scientists, because 3I/ATLAS is not just a comet, but a moving piece of evidence of the history of another star system. This is why it is being studied so intensely. And every new piece of data is adding a new understanding to astronomy. What is the XMM-Newton telescope, and what can it see? When observing mysterious objects like 3I/A/TLAS, ordinary telescopes simply aren't enough. This is where the ESA's Special Space Telescope, XMM-Newton, comes in. Simply put, XMM-Newton is a different kind of eye that sees the universe in light that we cannot see with our own eyes. It was launched in 1999 by the European Space Agency and has since been uncovering some of the most energetic and hidden secrets of space. Ordinary telescopes show us stars, planets, and galaxies because they operate in visible light. But there's much more happening in the universe that is invisible to the naked eye, such as high-energy collisions, hot gases, and the movement of charged particles. This is where X-ray astronomy becomes crucial. X-rays tell us where tremendous energy is being released in space, where temperatures reach millions of degrees, and where unusual processes are taking place. XMM-Newton is special because it is designed to detect X-rays. It has 3 large X-ray telescopes that can capture even extremely faint X-ray signals. In addition, it is equipped with instruments that can measure the energy of the X-rays. This allows scientists to understand what kind of processes produce the X-rays and what elements might be involved. Now the question is, what do X-rays tell us that ordinary light doesn't? Imagine a comet that appears calm to the eye, but is surrounded by high-energy particle collisions. This wouldn't be visible with an ordinary telescope, but it would be clearly detected in X-rays. This is why, when X-rays were observed coming from 3I/A/TLAS, scientists immediately understood that something energetic was happening around it. XMM-Newton doesn't just show us what is visible, but also provides glimpses into why it's happening. It has studied objects such as black holes, neutron stars, supernovae, and now, interstellar comets. Therefore, when such a unique object passes through our solar system, XMM-Newton reveals layers of information about it that remain hidden from both the naked eye and conventional telescopes. What is X-ray emission, and why is it unusual? When we hear the word X-ray, most people think of hospital machines. But X-rays aren't limited to Earth. The entire universe is filled with them. Simply put, X-rays are a form of very high-energy light. They are far more powerful than ordinary light, which is why our eyes cannot see them. In space, X-rays are typically produced in extremely extreme environments, such as around black holes, where matter heats up as it falls in, neutron stars, which are incredibly dense remnants of stars, or powerful explosions like supernovae, where immense energy is released all at once. In all these places, temperatures can reach millions of degrees, and that's where X-rays originate. That's why when scientists detect X-rays from something seemingly quiet, like a comet, it's considered unusual. Comets are generally thought of as cold bodies of ice, dust, and gas that gradually release gas and form a tail as they approach the sun. There are no explosions or extreme heat involved. So at first glance, there shouldn't be any reason for a comet to emit X-rays. This is why the detection of X-ray emission from a comet like 3I/A/TLAS immediately caught the attention of scientists. It wasn't an ordinary sight, but rather a signal that some unusual process was at work. Now the question is, how can a comet produce X-rays? The answer lies in an invisible but incredibly powerful stream of particles from the sun, known as the solar wind. The sun constantly emits a stream of high-speed charged particles. These include protons and heavier ions, which travel through space at millions of kilometers per hour. We don't usually feel it, but this solar wind affects the entire solar system. When a comet gets close enough to the sun, its ice heats up and turns into gas. This creates a large cloud of gas around the comet, called a coma. This is where the real action begins. Fast-moving, charged ions from the sun collide with this gas. This collision involves a process that scientists call charge exchange. In simpler terms, The ions from the solar wind steal electrons from the comet's gas. When this happens, the ion becomes unstable and releases its excess energy. This energy is often emitted as X-rays. So, the comet isn't actually producing X-rays itself, but rather generating them through the collision between particles from the sun and its own gases. This is why an X-ray telescope is needed to observe this phenomenon. In the case of 3I/ATLAS, this process becomes even more interesting because this comet is not from our solar system. Its gases and ice may have formed around another star. Therefore, when the solar wind interacts with it, the resulting X-rays can give us clues about how its composition differs from that of comets in our solar system. This is why detecting X-rays from a comet is not just a curious event, but a unique opportunity to understand the material from another star system. Why this process becomes more interesting in the case of interstellar comets. When it comes to an interstellar comet, the same process observed in ordinary comets suddenly becomes far more interesting and significant. The main reason for this is that 3I/ATLAS did not form in our solar system. It formed around another star, grew up in a completely different environment, and then traveled for millions or billions of years to reach here. Comets in our solar system formed in a similar environment, where the sun's heat, its initial chemical composition, and the rules governing their formation over time were roughly the same. But this is not the case with 3I/ATLAS. The star at the time of its formation would have been different, its heat would have been different, and the composition of the gases and dust surrounding it would also have been different. Therefore, scientists believe that the ice and gases of 3I/ATLAS may be slightly, or sometimes significantly, different from those of our familiar comets. When such a comet enters our solar system and interacts with the sun's solar wind, the X-rays produced not only provide information about the collision, but also hint at the material hidden within. If the composition of the gases is different, the energy and pattern of the X-rays emitted during charge exchange can also be different. This is what makes this entire process extremely valuable for scientists. Now the question arises, what exactly do scientists understand from this X-ray data? X-rays are not just light, but they contain information. Every element and every gas emits X-rays in a specific way. In simple terms, the color and energy of the X-rays can indicate the types of ions and gases involved. When telescopes like XMM-Newton record these X-rays, scientists analyze them to estimate which elements might be present around the comet, such as oxygen, carbon, nitrogen, or other light elements. In the case of 3I/ATLAS, this becomes even more crucial, because if it contains gases or ratios that differ from those found in comets in our solar system, it would be a clear indication that the chemistry of other star systems has evolved differently. This doesn't necessarily mean that life exists there, but it certainly suggests that things in the universe don't all conform to a single pattern. Every star, every system, tells its own unique story. Scientists are also using this X-ray data to understand how objects like 3I/ATLAS change over time, which gases are released from its surface first as it approaches the sun, and which ones later. All of this can be gleaned from the X-ray signals. This reveals the composition of its outer layers and what might be hidden within its interior. Most interestingly, this entire study gives us the experience of touching another star system without actually undertaking interstellar travel. 3I/ATLAS is, in a way, a sample of material formed around another star, which has traveled all the way to us. Through X-rays, scientists are trying to read that sample, like a book containing the history of another system. This is why the study of this interstellar comet transcends being merely a scientific event. It becomes a significant step towards understanding the universe. Does this provide any direct evidence of aliens or life? Whenever a new and unusual discovery related to space emerges, the first question that arises is Does this provide any direct evidence of aliens or any form of life? In the case of 3I/ATLAS and its associated X-ray observations, the answer is clear and straightforward. No, this discovery is not direct evidence of life. Scientists are very clear on this point. The X-rays from 3I/ATLAS are not proof that life exists or ever existed there. These X-rays are the result of a physical process in which particles from the sun collide with the comet's gases. But this doesn't mean the discovery is useless or merely a matter of curiosity. In fact, it helps us understand what kinds of objects form around other stars. Every star creates a different environment around itself. The ratio of gases can be different, the temperature can be different, and the composition of the objects that form over time can also be different. When objects like 3I/ATLAS enter our solar system, they bring with them a glimpse of that other system. This helps scientists understand how common the elements necessary for life, such as water, carbon, and other light elements, are in the universe. So, this discovery doesn't directly say there is life here, but it does indicate how many places in the universe the necessary ingredients for life can be found. This information further strengthens the search for habitable conditions. It's a small step, but a step in the right direction. Now, let's talk about the future. Why are such discoveries likely to increase in the coming years? The biggest reason is the rapid advancement of technology. Today's survey telescopes that scan the sky are far more sensitive than ever before. They are able to detect very small, very fast, and very distant objects. As these systems improve, identifying interstellar objects will become easier. In addition, telescopes that observe in different wavelengths, such as X-rays, will play an increasingly important role. Previously, we mostly observed things only in visible light, but now we know that the true story of the universe is often hidden. X-ray observations give scientists a new way to understand how energy is behaving around an object and what its composition might be. In the future, when a new interstellar object enters our solar system, scientists will not simply see it as a moving rock. They will try to read it like a message carrying the history of its formation around another star. 3I/ATLAS has made it clear that such objects are not merely fleeting visitors, but rather significant opportunities for scientific discovery. In the coming years, as such discoveries increase, our understanding of the universe will become even more profound. Before we end this video, I have a small request for you. If you enjoy learning about the universe, space, and mysterious scientific discoveries, please subscribe to the channel right now. You will continue to find interesting and informative videos like this one on this channel.